Welcome to the deep dive. Think about the internet. Use it for everything, right? Banking, watching shows. But the infrastructure, well, it's fast, yeah, but it has real limits. Your data can get snagged, signals fade out over distance. I mean, we're still dealing with physical fiber optics, electromagnetic waves. That basic physics still dictates how fast info travels around the globe. Now, imagine if data didn't play by those old rules. Imagine secrets that are totally immune to spying, clock syncing instantly across whole continents, distance just, not mattering anymore. Well, that future, it took this huge leap forward. November 13th, 2025, we've got sources talking about a material science breakthrough, something so big it's completely changed the game for global quantum networks. So our mission today is to really get into this innovation. We want to understand the science, the aha moment behind it all, and then look at what it actually means for the real world. Finance, healthcare, the impact this quantum internet era could have.
Yeah, and let's just state the core fact right away, because it's why everyone's talking about this. The breakthrough is about creating these new atom-crafted materials, and they let quantum links stay stable for, get this, 200 times farther than they could before.
Wait, 200 times? That's the shocker right there. Because for ages, quantum communication felt stuck, didn't it? It was great in the lab, sure, but very local, very fragile. Usually you'd hear about maybe, 1 kilometer?
Right.
Under perfect conditions.
Exactly, yeah. That 1 kilometer barrier was sort of the fundamental problem, the point where the quantum stuff, the coherence, just collapsed. This new tech pushes stable quantum links out to around 200 kilometers regularly. And that's not just, a little bit better. It's the difference between a cool lab trick and something you can actually build a global network with. It totally shatters that local distance limit. Makes a global quantum internet seem possible, like, overnight.
Okay. Let's dig into the how then. Before we jump to what it does, we need to understand the challenge they actually solved. So, the big problem before was keeping that quantum state going over distance coherence, right? Signals just faded, got messed up by noise, and poof, the quantum info was gone. Almost instantly. Too fragile, like you said.
Right. And what's really interesting, the solution wasn't a better laser or faster data transmission or anything like that. It was pure material science. Our sources are calling them atom-crafted repeaters. Think of coherence as, like, the quantum particle holding on to its special quantum identity. Decoherence is when it loses it, when it bumps into heat, vibrations, stray fields, all the noise in the world.
So the signal was just dying because the environment, the fiber, the air even, was too noisy for it.
Pretty much, yeah. The old ways couldn't shield the quantum state from all that noise. These new materials, these coherence kings, they're like the perfect little nests for quantum states. They're engineered atomic structures, lattices, that just dramatically slow down that decoherence. So instead of collapsing in milliseconds, the state stays pure, stays stable, for way, way longer inside these special repeater points.
Okay, that's a key thing for listeners, I think. It's not like boosting a weak light signal, like old repeaters do. It's about protecting the state itself, using chemistry and physics to basically clean up the path the signal takes.
Exactly. You're changing the physics of the journey, and this material breakthrough means distance is, well, it's becoming much less of an issue for quantum communication. We went from tricky meter-long experiments to reliably linking cities, potentially. And crucially, 200 kilometers is enough range to start bridging continents, using maybe existing fiber hubs or satellite links.
Okay, so if distance is basically solved, or at least massively improved, what's the first thing this changes, the first big application? Security always seems to be the headline.
Unbreakable encryption, that's the immediate, guaranteed win. It's what some sources are calling a privacy paradise. Eavesdroppers are just blind. And this isn't just like a slightly better password. It's based on quantum mechanics. The rule is, if you try to observe an entangled state, you automatically disturb it, you collapse it. So any attempt to hack or listen in, the sender and receiver know instantly.
So the very act of trying to steal the information destroys it and sets off an alarm.
Precisely. It's the ultimate do not touch sign, enforced by physics. Makes all the old ways of hacking kind of pointless. It's a fundamental change for protecting everything, government secrets, your bank details, everything.
Wow. Yeah, that alone is massive for cybersecurity. But, okay, beyond security, our sources also talk about something else, maybe less obvious: instant global synchronization.
Yes, the times tango, as one source put it, because quantum information links up instantly, entangled particles react together regardless of distance. We'll cross these new 200-kilometer links anyway. You can get clocks or even, like, computational processes perfectly synced up worldwide.
Instant sync. But hang on, don't we already have super accurate clocks, like GPS and stuff? Why is quantum sync so much better than what we have now?
Good question. It's about propagation delay. GPS signals in fiber, that travel at the speed of light,
Mm.
which is fast, obviously, but not instant. Over long distances, tiny delays add up. Quantum entanglement, though, the connection is instant within that link. So synchronization based on that removes the distance delay. Systems can align perfectly, like they were literally side by side.
Okay, I see. And that kind of nanosecond perfect timing, that must have huge implications. You mentioned finance, high frequency trading.
Oh, absolutely.
Oh,
It would completely rewrite how global markets operate. No more tiny delays giving one trader an edge over another purely because of geography. But think bigger, too. Air traffic control, managing satellite fleets, stabilizing massive power grids, anything complex and time critical gets way more efficient and reliable. If every system is truly on the exact same clock tick, it enables a level of global coordination we just couldn't achieve before.
right. And this is where that 200x range really starts to unlock things, isn't it? If you can link quantum processors this far, are we talking about the start of a true quantum cloud?
We absolutely are. This material breakthrough makes that whole vision practical, not just a theory. Quantum computing stops being just this isolated, specialized thing in a few labs.
Yep.
It becomes a potential global utility. You could have quantum servers entangled across continents,
No.
a cloud unbound. Imagine accessing specialized quantum power from thousands of miles away, but with zero lag, like it's right there on your desk.
Okay, a global quantum cloud. Connecting that to AI, that sounds potentially, well, both amazing and a bit scary. The sources talk about AI superteams.
Yeah, the idea is that AI systems, bots, could link up using quantum entanglement. In superposition, they call them thought collectives. The suggestion is they become much smarter together than any single AI could be, because they're sharing quantum resources instantly across the network.
Okay, hang on. Linking and superposition. Let's unpack that slightly. Superposition means a quantum bit can be 0 and 1 at the same time, right? So what does shared superposition mean for two AIs 200 kilometers apart?
Right, so instead of just sending results back and forth, bits of data, ones and zeros after they've done some thinking, they're sharing the potential outcomes. While they're still thinking, if they're linked quantum fast, the total number of possibilities they can explore together just explodes. They can process information, explore options, almost like one enormous distributed quantum brain. It could dramatically speed up how complex AI develops.
And that power, combined with the security, brings us to healthcare. The sources mention medical teleport, which sounds very sci-fi.
Huh, yeah, maybe a bit. But it's really about secure, instant data sharing and collaboration. Imagine really complex medical data like high-res brain scans, real-time readings from sensors, huge gene sequences, zipping across the globe instantly through these unhackable quantum channels. It creates health horizons. Diagnosis isn't stuck by geography anymore. A top specialist in, say, Tokyo could look at real-time data for a patient in London, totally securely, with zero delay or data loss, and help with the diagnosis.
Yeah, and if we pull back even further, connect this to the really big picture. This isn't just, faster video calls or safer online shopping. It could change how we manage knowledge globally, how we use resources, even how we think about sustainability.
Right, the sustainability point. We know current digital stuff, data centers, networks, they use a ton of energy, especially sending signals long distances, needing constant boosting. So these new quantum links, thanks to the materials, they're low loss, you said. That's the key.
Yeah.
Sending quantum information 200 kilometers without needing those energy-guzzling classical repeaters all the time. That means you get incredible performance with potentially much less waste. It makes quantum comms a potential planet's ally. High speed, but maybe more efficient than scaling up our current networks.
And importantly, this isn't just for huge organizations or governments, is it? The idea is to bring it down to us, the users.
Yeah.
Everyday entanglement.
Exactly. The sources suggest a future where your phone, maybe even your car, goes quantum.
So my phone gets a secret superpower. It doesn't need a quantum computer inside it necessarily, but it becomes a device that can tap into this new global network, communicate securely, access those quantum cloud resources we talked about.
That's the vision. Making this power accessible everywhere, localized for everyone, which leads to the ultimate kind of visionary goal here, the unity upgrade.
This is the idea that a truly global quantum net could sort of end isolation, wrap the planet in these instant, secure connections, leading to what the sources call connected consciousness. A bit out there, maybe, but it's the ultimate promise if distance truly becomes meaningless for sharing information.
It's definitely a profound idea, a future where maybe those old barriers, geographic barriers to knowledge and connection, just dissolve.
Okay, so let's just quickly recap. This has been a whirlwind. We had the November 2025 breakthrough, these atom-crafted materials, the repeaters. That enables the huge 200-kilometer leap in distance for stable quantum links. And that single step suddenly makes things like truly hack-proof security viable, instant global time sync possible, and opens the door to worldwide AI teams, borderless quantum computing, the whole lot.
Yeah, and what does this mean for you listening? Well, this jump from delicate lab stuff measured in meters to robust 200-kilometer links, it suggests the future we've been talking about for years. Quantum computing, total privacy. It might be arriving a lot faster than we thought. The basic building blocks for the next generation of, well, almost everything, from medicine to money, they now seem physically possible to build globally.
It really is transformative, but it does leave us with a pretty big question to chew on, doesn't it? If you get perfect global sync of time and information, and if this connected consciousness is the end goal, what happens to like unique regional ideas or distinct local economies?
Right. If the whole world's mind can align instantly, does local difference just fade away? When distance stops creating separation, what does that do to regional identity? Something definitely worth thinking about as these quantum threads start weaving into our world.
And that's all we have time for on this deep dive. Thanks for linking up with us today as we explore the dawn of the quantum internet.